Friends, welcome to CS Academy. The last class we are discussing about the strength of materials paper discussion. Now in this class we will discuss about the some of the quick revision topics in strength of material. The concepts will be the one of the concepts will be the beams and the types of beams, and next one is automatically and types of supports. And in these types of supports we will discuss about the hinged support, roller support and fixed support, and after this we will discuss about the types of loads and how the varies from SFD diagram and BMD diagram in beams. And the next concept is it is related to the beams. In this one of the point is point of contraflexure. This is the one of the point is very important point, and they will ask you questions, and this is the main area. It is related to the in beams, and this followed by the next one of the next concept is the bending moment equations, and that is m by I is equal to f by y is equal to e by r, and it is followed by the torsion equation, and T by J is equal to tau by R is equal to G theta by L, and it is followed by the next one of the following equations. It is a strain energy concept. In the strain energy concept you have to know about the resilience and proof resilience, and the next concept is modulus of resilience, and that one more very important topic is strain energy is we are applying sudden to stress induced in the sudden to the gradual. What is the relation between these two? And in this we will discuss about all these things. Finally, in this class we will discuss about the first. We are focusing on the beams, and in the beams what is the types of beams already we are discussed in the last class types of beams, and it is followed by the types of supports. In the types of supports, what is the different types of supports: roller support, hinge support and fixed support, and followed by the what is the types of loads. The types of loads will be what is UDL, UVL and point load, and how it varies from SFD and BMD diagram. And one more thing is that point of contraflexure, and some of the important terms, how it will be varies from shear force and bending moment diagram, where the bending moment changes its sign, where the shear force changes its sign. In this concept we will discuss all these things, and it is followed by the bending moment theory of bending. It is a bending stresses, and this bending stresses it is a equation. It is a m by I is equal to f by y is equal to e by r, and it is followed by the torsion equation. T by J is equal to tau by R is equal to G theta by L, and it is always followed by the one of the important concept is in the shear stresses in beams. Shear stresses in beams, it is always we have to know that. This is also we are discussing this, and it is followed by the next one more important concept is strain energy. This strain energy, how it is varies from the for what is resilience, what is proof resilience, what is modulus of resilience, and how it is varies from sudden to the gradual, and we will discuss all these things in this class. First of all, in beams we have to know that first of all we have to know this is what is a type of a beam, and after this we have to know the type of the support, and after this we have to know about the type of loading. And in these different classifications we have to know each and everything. First of all, in the type of support it will be a what is this SS? It is called as a simply supported beam. Just simply supported means only the supports will be two ends only, and after this we will discuss each and everything. And the next type of beam is a cantilever beam, cantilever beam, and the next support will be the continuous supports, and the next support will be the overhanging beam, and the next support will be the fixed type of beams. And finally this is the different types of beams will be here. First of all, first support is a simply supported beam, next one is a cantilever beam, and next one is a overhanging beam, next one is a continuous beam, next one is a fixed support beam, and next one is a what is the different supports will be there. That supports will be the first support it will be a roller support, and next support it will be a hinged support, and next support it will be a fixed support, and that means different supports will be there here. This supports will based on that. Suppose if it is one hand is hinged and other hand is roller, that support will be a simply supported. Suppose if one hand is fixed and other hand is free, that is called as a cantilever. Suppose if both ends are fixed, that is called as a fixed beam. See the number of supports, the number of hinge support and roller support, the combination of hinge support and roller support is a combination, it is called as a continuous beams. And see here, and these supports will be required based on these supports the beams as classified. And again in that different supports and different beams, what type of loading you are applying. That loading you are applying as a point load, or it is a UDL, or it is a UVL. What is UDL? UDL means uniformly distributed load. Uniformly distributed load, and these units will be the always Newton per meter. Why it is Newton per meter means it will be that units will be the distance. Now uniformly distributed load. Uniformly distributed load means per 1 meter length how much amount of force it will be acting. The point load, that just simply this will be a load, the units will be the newtons. And see here that uniformly varying load, that means uniformly varying load means it is uniformly the load it is distributed. Now each and everything we will discuss all these things in detail. And see here, uniformly varying load means it is uniformly it is varying. See here, initially this will be the zero load and slowly the load gets increases. Again in one more you can represent in this manner also. Suppose if it is the load here, it is in the uniformly varying, either it is in the upward direction, either it is in the downward direction, there is no problem. That means whatever the load it is acting either in upward direction, either in downward direction. Finally in the beams we have to know that first of all what is a type of beam, and you have to know the what is the type of support, and we have to know the type of loading also. This type of loading is very important, and based on the type of loading, point load or UDL and UVL, now we will discuss each and everything. And it is a combination of with combination of beams, and this combination beam with loading, it is you are applying in the type of beam. Simply supported is a combination with the point load, simply supported is a combination with UDL, simply supported with combination with UVL. Same in the similar manner, cantilever it is combination with a point load, cantilever is a UDL, cantilever it is a UVL. And either same thing in the overhang beam is also point load, overhang beam with UDL, overhang beam with UVL. That means the beam it is combination, it is with a type of loading, and we have to know each and everything. Now I will explain each and everything clearly. Yes, first it is a simply supported beam. Simply supported is a combination with a point load, simply supported with UDL, and simply supported with UVL, and always it is combination with a point load and UDL loads. And but in our syllabus only we are limited to the point load and UDL for a different beams. Now first we will see the what is point load and what is UDL, what is UVL, and point load combination with a UDL. But in our syllabus only point load and UDL will be there. Suppose if it is first of all what is simply supported. In the simply supported means one hand is hinged and other hand is roller. This is called as a simply supported beam. First of all, what is the main criteria? In the main criteria, one hand will be hinged and the other hand will be roller. This will be called as a simply supported beam. In the simply supported beam, suppose if that load will be applied, the load, suppose if it will be load is a 10 kilonewtons, that is called as a point load. This is called as a simply supported with point load. That means simply supported with point load, that load will be acting at any location. It may be either center, it may be it reaches to the hinged support, it near to the hinged support, it may be near to the roller support. That is depend upon the type of loading, and based upon that location it is differs from place to place. And but now convenient I drawn middle, and this support will be it is a point load. That load will be either represented in newtons or kilonewtons. And next combination will be a simply supported with point UDL. Simply supported with point load means, first of all, what is the main criteria? Simply supported means one hand will be hinged and other hand will be roller support. This roller support is a combination with a UDL. See here, this is a combination of UDL. This UDL, some of the people, they are represented as, this is the representation of the, some of the people, they are represented like it is a rectangle. This is also UDL, but this UDL, that here the units will be the 10 kilonewton per meter. You have to represent like this. Why you have to represent like this means, per meter this much amount of load will be acting. What is the meaning of this means, per meter, this meaning 10 kilonewtons load will be acting. Suppose this is entirely 3 meters, that means 3 meters, so how much amount of load will be acting? For 3 meters it will be 30 kilonewtons. Where you have to represent, you have to, in our convenience, you have to represent this UDL, you convert into a at point load, exactly it is at a center, this will be the 30 kilonewtons. You have to represent here, you converting UDL into point load, but the representation is that exactly you have to represent as a center, but whenever you are representing as a UDL, that UDL it is followed by the kilonewton per meter. Per meter, how much load will be acting, how much amount of load will be acting here. This, suppose if this will be a 3 meters, that 3 meters it will be a, for 1 meter this will be 10 kilonewtons, for 3 meters it will be 30 kilonewtons. But how you can represent this 3 meters 30 kilonewtons? It is exactly its center, that means here it is 1.5 meters and here it is 1.5 meters. Exactly you have to represent like this. And this point load is simply supported with UVL. It is not there in our syllabus, but for the sake of understanding I will tell you what is UVL. See, UVL means it is a uniformly varying load. See here, this is initially, this will be the one end, this will be the other end, that load will be varies from one end to the other end slowly. It is increases slowly, that means it is uniformly varying, that load may be increases varyingly, that is representation of uniformly varying load. This uniformly varying load you can represent here in this manner, or otherwise you can represent in this manner also. From it is moving from left to right, or it is left to right to left, or right to left, it is either bottom to top or top to bottom. There is no problem here, but uniformly varying load means from one end to the other end the load will be varying, uniformly varying load. And the next will be the combination of a point load with UDL. Point load with UDL means, see here, this is the point load, and suppose here this is a one more point load, this will be a 20 kilonewtons, and it is representation, it is one more load 10 kilonewtons. Here this is the UDL it is acting, that is a UDL, it will be the 10 kilonewton per meter. The total length will be the 5 meters. If the total length will be the 5 meters, this will be the, this is acting at 1 meter, this is acting at 2 meters, and this is acting at 2 meters, and this means entirely this load will be acting at, this load will be acting at 2 meters. That means it will be the, finally the total load will be the 20 kilonewtons. This is a combination of point load with UDL. Finally, what you understood by this means, in this different beam, in the simply supported beam, what is the different loads they are applying, and based on that loading, that diagram will be changes. Sir, why you are representing all these things means, you have to find out maximum shear force and maximum bending moment. That is a lead to this shear force diagram and bending moment diagram, where the maximum shear force it occurs and where maximum bending moment is occurs. Why you are finding out the maximum shear force and maximum bending moment means, you are applying transverse load. Whenever you are applying transverse load on a beam, that beam induces shear forces, maximum shear forces. At the same time, the beam it is bending happens. In that, you have to, where it is maximum shear force it happens, where maximum bending moment it happens, you have to find out each and everything. For that, you have to calculate the shear force diagram and bending moment diagram, and it is considering as a maximum shear force and maximum bending moment. This is only related to the shear force, simply supported beam with a combination of different loading conditions. Now we will discuss about the next one is the cantilever beam. That cantilever beam, again it is a similar manner. It will be a point load and it will be a UDL and it will be a combination of UVL and it will be a combination of point load plus UDL. And that means each and everywhere it is a combination this happens, but in our syllabus this week these two will be there, and there is a chance to draw that, ask that point load plus combination of UDL. See here in cantilever with point. First of all, what is cantilever? Cantilever means one end will be fixed support and other end will be free. See here, this other end will be free. One end will be fixed support. These practical examples will be like it is our sunset. This will be one end fixed and other end will be free. Like our coconut trees, our current poles, all will be one end fixed and other end will be free. Suppose if it is this is one end, this is other end. Suppose if you are applying other end at a other end, you are applying point load. This will be the, suppose if the load will be 10 kilonewtons. This is called as a cantilever with the point load. This cantilever with point load. This is if it is a 2 meters length. If the 2 meters length, if the point load it is acting here, this is called as a cantilever with the point load. The load will be here. It is not only at a end direction. It is not in the free end direction. It may be load may be here. It may be load may be here. It may be load may be here. This is called as a cantilever with point load. And next one is a cantilever with UDL. This cantilever with UDL, it will be not a thing. Just it will be the, just we are discussing what is UDL. UDL means it is a uniformly distributed load. Uniformly distributed load means 10 kilonewton per meter. Suppose if it is 2, whatever the load it is there, that load is uniformly distributed throughout the length. See here, this is a beam. This whatever the cantilever beam will be there, that load it is each and everywhere uniformly distributed from one end to the other end. It is uniformly distributed. This is known as a uniformly distributed load. This is a combination of cantilever with UDL, uniformly distributed load. This is representation will be like this. Representation it is in some people they are representing in rectangular manner. Some people they are representing with a diagram. This is the representation. This is the notation 10 kilonewton per meter over a 2 meters length. This is also one more representation of a cantilever UDL. And the final thing is the UVL. UVL means it is nothing is there. Suppose if it is the representation is cantilever representation is here. UVL, it is a UVL representation. The uniformly load will be varying. This is a cantilever with uniformly varying load. And the next combination is a point load plus UDL. It is a combination of a point load and it is a combination of UDL. And combination of point load plus UDL is a, suppose if it is the cantilever beam, this cantilever beam, this will be the point load and this will be the UDL. And see here, this will be 10 kilonewton and this will be 10 kilonewton per meter. Wow, this is important, 2 meters length. And here total length will be the 5 meters. That means we have to represent where it will be, what is the length of the UDL. You have to represent. Y means per meter this will be 10 kilonewtons. For 2 meters it will be 20 kilonewtons. For that you have to represent the length of the UDL will be, you have to represent, and the total length you have to represent. The total length of the cantilever beam will be the 5 meters, and for that you have to represent. This is the representation, and this is called as a cantilever applications. This is cantilever with point load, cantilever with UDL, cantilever with UVL, combination of point load plus UDL load. See here, now we will discuss about the in detail. This is a very important chart for the understanding the what is the type of beam, type of load, and SFD and BMD diagram. SFD means it is a shear force diagram. BMD means it is a bending moment diagram. In the first you have to know that what is the type of beam. The type of beam will be a simply supported. Now what is the type of loading? The type of loading will be a point load or UDL load, and how it will be shear force diagram will be varies, and how it will be bending moment diagram will be varies. Just now we are discussing the two types of beams and two types of, one is a simply supported beam and another one is a cantilever beam. And this cantilever beam, it is a point load and it will be UDL. First of all, how the shape if simply supported with point load. How you can represent simply supported with point load means, see here, this will be a simply supported with point load. This is the representation of simply supported point load. This simply supported point load, it will be a, whenever it will be a rectangle, this will be a triangle. That means one more order will be there, triangular will be there. Or how you can represent, just it is a 1 degree more than that. Suppose if it is a point load, it will be a rectangle, it be BMD, bending moment diagram, will be a triangle. Suppose if it is in the UDL, it will be shear force diagram will be a triangle, this will be a parabola. And see here, this is only applicable to the simply supported with UDL. This is simply supported with point load. Whenever it is a simply supported with a point load, this will be rectangle. That rectangle only for a shear force diagram. And the bending moment diagram, it is only for a bending moment diagram. It is, the shape will be the triangular shape. And now what you understood by this means, it is a simply supported point load, the shear force diagram will be rectangle. For the simply supported point load, the bending moment diagram will be triangular. Suppose if it is simply supported with UDL, the shear force diagram will be triangle. And suppose if it is simply supported with UDL, the bending moment diagram will be parabola. Finally, what you understood by this means, if it is a rectangle, it will be a triangle. If it is a triangle, it will be a parabola. That means only 1 degree more than that. That is the indication of this diagram. And same thing, now you are coming to the cantilever with point load. In cantilever with point load, it will be a triangle and it will be a parabola. And how I will explain that parabola. And suppose if it is a parabola, here in this case, in the parabola, there is a 2 types will be there. One is a second degree parabola, and this is also in parabola in the bending moment diagram, but this will be a 3rd degree parabola. Finally, what you understood by this means, it will be a 3rd degree parabola, just it is a 1 degree more than that. 1 degree more than that means, here second degree parabola, it will be a 3rd degree parabola. Finally, this is a different types of beams, different types of loads for that SFD and BMD diagram. Again, I will explain that. Suppose if it is a simply supported point load, the shear force diagram will be rectangle. The bending moment diagram will be triangle. Suppose if it is simply supported with UDL, the shear force diagram will be triangle. The bending moment diagram will be parabola. Suppose if it is a cantilever beam, that cantilever beam with a point load, the shear force diagram will be a triangle and the bending moment diagram will be a parabola. If it is cantilever with UDL, type of beam is cantilever, the type of load will be UDL, uniformly distributed load. Cantilever beam with UDL load, the shear force diagram will be a parabola. That parabola is also second degree parabola. And see here what is the representation of second degree parabola and 3rd degree parabola means, just that is a parabola. Suppose if it is here, the diagram will be just this will be the parabola. This is representation of parabola. See here, this is a just it is a parabola indication. And 3rd degree parabola means just nothing is there, just it is a more slope will be there. This is the representation. This is a more slope. This is a second degree parabola and this will be a 3rd degree parabola. Parabola is same but degree will be changes. From UDL, it will be shear force diagram to bending moment diagram, just 1 degree increases. That is the meaning of this. Finally, this is very important chart and you will get a 1 question from this. This is related to the type of beam and type of loading, how the shear force and bending moment diagram is varies. You have to remember this chart and you have to understood this chart. Based on this chart only, you have to draw the each and everything, every shear force and bending moment diagram. In this concept, you have to know that some of the terms will be the moment. First of all, what is meant by moment? Moment equal to force into perpendicular distance. See here, what is meant by force into perpendicular distance means, suppose if it is here, this will be the load will be acting here. Now it is a cantilever with a point load. Suppose if cantilever with point load, the load will be 10 kilonewtons here acting here. Suppose if it is a 2 meters, so how you can calculate moment? Moment equal to force into perpendicular distance. Force into perpendicular distance. What is the force will be there? That force will be 10 kilonewtons and the moment will be 2 meters. the distance will be 2 meters. What is the moment will be? Moment will be 20 kilonewton meter. That means what to represent? It will be the moment equal to force into perpendicular distance. Finally, what you understood? Moment is equal to force into perpendicular distance. What is this force? That force is equal to shear force. This distance is a perpendicular distance. Suppose if moment is equal to shear force into distance. What the shear force into distance means? Suppose how you can write shear force? Shear force is equal to, you can represent it as a moment by distance. That moment by distance, it is, suppose if the shear force it is varies, shear force it is varies from one portion to the other portion. If that here in this diagram the shear force it is varying from 0 to 2 meters, that this is the shear force diagram. This shear force diagram it will be varies, and that means it is varies from 0 to 2 meters, and it is varies from 0 to 2 meters. Thus it is the formation, it will be a, the shear force diagram it will be a triangle. When the shear force diagram it will be a triangle, and that means the shear force it is varying. Here the shear force is 0, here the shear force is 0, and here, see here, see here, this is the moment it will be 0, and see here force into distance, moment will be 0, and whenever the moment will be 0 means how you can moment will be 0? Here the distance will be 0. When the distance will be 0, here the moment will be 0. Force into perpendicular distance, force will be there but there is no distance. See, goes on, the moment increases. The maximum moment happens at what is the location? The maximum moment happens at a fixed support, and that fixed support means that is shear force. Actually, what is shear force? Maximum bending moment equal to shear force into distance. That means shear force equal to moment by distance, and that means that moment it is also varies from distance to distance, and that means it is varies from shear force equal to moment by distance. Finally, that moment by distance it gives as a shear force. Same in this manner, the shear force varies with respect to distance. It is called as a intensity of loading. What it is called as this? How you can represent this representation of the shear force? It varies with respect to x direct, with respect to distance. This is known as intensity of loading. This is how you can represent this moment by distance. It varies, it is called as a shear force. This will be the shear force, and the shear force varies with respect to distance. It is called as intensity of loading. This is very important, intensity of loading. Intensity of loading you are represented as a Newton per meter, and shear force units will be the newtons. These two terms are very important. First of all, what is this? That what it represents? It is moment which changes with respect to distance. It gives a shear force diagram, and shear force varies with respect to distance. It gives an intensity of loading. This is important question they will ask you. From what is the basic of this? Actually, moment is equal to force into perpendicular distance. What is that force? Force is equal to shear force. The shear force equal to moment by distance, and you can use this equation. Moment varies with respect to distance. See here, moment varies with respect to distance. Here in this case the moment will be 0. In this case the maximum bending moment will be happens. Where the maximum bending moment will be happens? In cantilever beam at the fixed support. Why it will be the maximum bending moment? And it is a more distance, and moment it is only depend upon a distance functions only that whenever the distance varies, the moment it is also varies. And what is that force? F is a shear force, and this is the importance of the shear force and intensity of loading. That units will be the Newton per meter, and the shear force units will be the Newton shear. Important concept is the point of counterflexure. First of all, what is point of counterflexure? That means flexure means it will be happens in a bending moment. Bending moment means where bending moment changes its sign. When bending moment changes its sign means its representation, it is indication as most of the cases it will be happens in a overhanging beams, and after that it will be happens in a continuous beams. And this is the question the last time they are asking in exam, engineering external exam. First of all, where it will be happens? It is in most of the cases it will be happens in overhanging beams. First of all, what is overhanging beam? Overhanging beam is one, and this is the support. Sometimes you can represent it like this. Suppose if it is a simply supported and other end is will be free, and this is also called as overhanging beam. And other way you can represent it as, suppose if it is a support and this is the support and this is the gap you are maintaining here, and this is the gap you are maintaining here, this is also called as overhanging beam. And suppose if that gap, it is the whatever the distance gap, suppose if it is the gap here, the distance is a, suppose if the distance is the total length, it will total length of the 4, it will be less than that L by 4, this will be the counterflux. It is happens here. Suppose if it is, if you maintain L by 4 or it is greater than L by 4, there is no point of counterflux will happen, there is no bending moment changes its sign happen. Whenever it bending moment changes sign it happens, means whenever the distance is, the distance it will be a, it will be less than L by 4, at that case only the point of counterflux will happen. At that time the bending moment changes its sign, it will be happens here. Suppose if in this case the whenever the distance it will be a is less than L by 4, at that time only the bending moment changes its sign to in this manner. That is that is the representation. And see here, this is the representation of whenever the distance will be a is less than L by 4. See here, this is the bending moment diagram. In this case only the bending moment changes its sign. See here, this bending moment here, initially this will be negative, now it will be a positive, and again it will be a negative sign, and it changes from positive sign to negative sign. What is point of counterflux? Point of counterflux means bending moment changes its sign. Changes its sign means negative to positive and positive to negative, and it will be in any direction. Negative to positive and positive to negative, it will be anything, but here it happens from negative to positive and positive to negative, and it is moving from the bending moment changes its sign from negative to positive, positive to negative. That means finally it changes its sign. This point is called as that particular point is called as point of counterflux. This is very important thing. First of all, bending moment changes its sign. Mostly it happens in case of overhanging beams, and next one in case of a continuous beams. This is the last time they are asking this question. Portion, the last concept, it is a different type based upon type of beam, type of load, where the maximum shear force it happens, and where it is the maximum bending moment it happens here. Suppose if it is a simply supported beam, and it simply supported beam with point load, the maximum shear force it happens at a W by 2, and the maximum bending moment it happens at W L by 4, and based upon the equations we have to remember these equations where it will be happens W L by 4. And see here, and next one more thing is the based upon a type of beam and type of loading. It's simply supported with UDL, the maximum shear force happens at a WL by 2. See here, this is WL by 2, and where it is the maximum bending moment happens in WL square by 8 in case of UDL. It is very important. This is a guarantee one of your question. It is in the next coming exam. This will be very important. In a simply supported with UDL, the maximum bending moment happens at WL square by 8. Same in the case of in cantilever. In cantilever, the type of load will be a point load. The maximum shear force it happens at W, and the maximum bending moment it happens at WL, and just it is a simply WL. See here, in this case it is only WL by 2. In case of W means this is a WL by 2, it will be a intensity of loading. This will be a WL square by 8. This is the intensity of loading. This is only normal load, and this will be the uniformly distributed load. Cantilever with uniformly distributed load, this will be WL, and this will be WL square by 2. See here, this is W, this is W intensity of loading here, and this will be the normal load, point load, that will be WL here. In case of maximum shear force it happens in case of UDL, this is WL, this will be WL square by 2 only. This is very important. This data is very useful, and with this data any question they may be asked in the next coming exams, the future coming exams. It is very important, and you have to remember this. You have to mark up these formulas based on the type of loading. It will be in case of point load, it will be W by 2. If in case of bending maximum bending moment, it will be the WL by 4, and if in case of in UDL, that UDL it will be WL by 2. In case of maximum bending moment, WL square by 8. If in case of cantilever with point load, that will be load will be W. In case of maximum bending moment, it will be WL. If it in case of cantilever with UDL, this is maximum shear force will be WL, and it will be the WL square by 2 here. This is the concept. It is related to the entire strength of materials. This out of this we will get a one question. This is related to the shear force and bending moment diagram. This is very important thing. Finally we will get it this. Thank you for the watching, and the next coming sessions we have to discuss in further topics. That further topics it will be the strain energy concept. Another one is a bending stresses and torsion shear stresses. It will be discussed the next coming classes. This is that. Thank you for watching. Please subscribe and share it to your friends. This is information related to the strength of materials class 2 quick revision. Thank you for the watching.